We are now going to begin the entire reason that we have started with summations, which is we are going to start trying to determine the asymptotic complexity of a given summation. So here, we're going to see the summation we've dealt with the most so far, the arithmetic sum, when we add from 1 to n of I, and try to determine the complexity of that. This, thankfully, as we have seen in the previous videos, we have a formula for. So let's begin with that. T of n is equal to that summation. I goes from 1 to n of I. And we have a formula for that. It is the top bound times the top bound plus 1 divided by 2. So this is n times n plus 1 divided by 2. And we need to determine the complexity of that. You might look at that and go, I don't quite know what it is, but we just want to try and come up with a guess. We are then going to bound this above and below because we're trying to determine what it is in theta of. So to do that, we're going to use all of our techniques we developed in the past. So I'm going to bound this above using the techniques that we learned in the past. I'm going to replace the 1 with an n and keep everything else the same. Off to the side, I need to make sure I know that that's true. When is 1 less than or equal to n? Well, that's n greater than or equal to 1. And now let's keep doing algebra. This becomes n times 2n divided by 2, which is just n squared. So it's bounded above by n squared, which is good, because I probably suspected that here because it looked like n squared. We now need to bound it below. To bound it below, remember, we can drop positive terms that do not matter. So to bound this below, we are going to take the quantity that we had, duplicate it, put it down here. It is greater than or equal to, we can drop the plus 1. It is a positive term. Therefore, we can remove it when bounding below. And we're left with n times n divided by 2, which is just n squared divided by 2. So we have bounded this quantity above by a constant times n squared, 1 times n squared. We bounded it below by a constant times n squared, 1/2. So therefore, it must be in theta of n squared. Let's explicitly tell the reader what our C1, C2, and n naught are. C1 is the constant that multiplies the lower bound, so that's 1/2. C2 is the constant that multiplies the upper bound, that's 1, and our n0 is 1, because n needed to be at least 1 in order for my first step for my upper bound to hold. Therefore, we are going to say that this is in theta of n squared. So, my final conclusion is that t of n, that function that represented the summation, is in theta of n squared. Notice, step 1 was use a formula, and then we started bounding above using our rules for bounding polynomials and other expressions from above and below. All of the things we did in asymptotic notation hold once you've used that summation formula. So sometimes you have a known formula for your summation and can just use the techniques we've done in the past to analyze this. This may not always be the case, as we will see in future videos, though.